All right. Good evening, everybody. Good evening. So today we are going to do some revision for chapter 3, Gravitation, as your request. Okay. Now, wait. Give me 1 minute. Now, if you are interested in next year timetable online tuition, so you can click this link. I send it to here. Okay. Now, I send it to here. 2024 physics online tuition. If you are interested, you can click this link, or you can save this link. You can, if you don't register, you can go and view the timetable also. All right. And the next thing is, next year, if not mistaken, next year, your SPM Amali will be held on October. All right. Whereas now, yesterday, yesterday, physics Amali have done. All right. So it is at December. So have to be bring forward. Right. Mean earlier by 2 months. 2 months. If 2 months. If next year you want to start your Form 5 tuition, we will start on January. So if not, cannot finish one. I tell you, I cannot finish. Other teacher, I don't know, right? But me, I cannot finish, right? Okay. So now this is my complete notes. If you are joining my tuition, you are having these notes, right, for you, right? But not printed one. It is a soft copy, so you have to print it out on your own. And these notes, it is easy to use, right? It is the thing that I write on my own. Inside got a lot of stat paper, so we are going to do revision, right? Like for example, you want to study, what is Kepler law? So what you need to do is you just press this Kepler, then you will go to page 39. Page 39, Kepler law number 1, Kepler law second law, Kepler law number 3. You can have, but of course there is some error that I have done, so I will do it on the spot for you. Alright, I will do the correction for you. Okay, now today we are going to start to do the 7:30. We wait for a little while lah. While we are wait for a little while, so I answer one question first. Give me 1 minute. While we are waiting, normally 7:30 lah, right? But I will normally start. My style is my tuition I will start 7:20. So if a spaceship of the weight of the 9 times 10 power 6 of the surface of Earth, calculate the weight of the spaceship when it is at the distance of 3r from the Earth. All right. W is equal to mg, whereas mg is equal to F is equal to gmm over r squared. So hard for me to write here. Give me 1 minute. Okay. Now you substitute this mg to F. F is equal to W, right? F is a force. Weight is a force. So mg is equal to gmm over r squared. So now what you have is mg. Mg is equals to gmm over r squared. We build the formula first. This is the question asked in the Telegram group. Right? If you got any question, even you are not my student, you can ask question there, my Telegram group. I'll send the link for you. If you are not joining my Telegram group, where here. Here. This is my Telegram group. If you want to ask me question there, you can ask here also. Okay. So I cancel the M. Right? So G is equals to GM over R squared. Now, if this one I want to substitute the G first, right? At first, your G is GM over R squared. Now, your R is big R. Okay? So G is equals to GM over R. Right? G is GM over R square. Okay. So because of big R, capital letter R, it is our Earth radius. Now what happened is, now your new G prime is equals to new G, GM over R squared. Your R is, what is your R right now? R is become 3R, right? 3R. So hard for me to write. If I can write in formula, it will be better, right? But this is pen, so I cannot write in formula. Okay, so now what happened is, I use this way to write it faster. So G prime, it is equivalent to GM over 9R squared. So I bring this 9 out so that it's easier for you to see. So it is GM over R squared, and then you still got 1 over 9 here, time 1 over 9, right? Okay, 1 over 9, right? 1 over 9. So I am going to substitute this one already. Now they gave us W is equals to mg, right? What is your W? W is 9 times 10 plus 6, right? M, I don't know. G, I also don't know. Whereas now the new G is, sorry, the M, I don't have it, right? M, I don't have it. So it is mg, right? Mg. So I leave it as 1. Okay. Now, the new weight, I don't know, right? It is equal to the same mass, right? G is the new G. New G is 1 over 9 of previous G. This is G, right? 1 over 9 G. So 1 over 9 G, right? So number 2. All right. So what is the new weight? So I divide by first equation with the second equation. Second equation divide by first equation. So what I have is W over 9 times 10 to the power 6 is equals to, number 2 is 1 over 9 mg, 1 over 9 mg divided by mg. Whereas this mg I can cancel, right? So I'm going to time this one up. So weight is equals to 1 over 9 times 9 times 10 power 6, right? So 1 over 9 times 9 times 10 power 6, 9 exponent 6. So I am going to get as 1 times 10 to the power 6. So I get 1 times 10 to the power 6. The new weight, it is 1 times 10 to the power 6, right? Newton. Answer is A. All right. Okay. Let me, that one. Okay, reply already. Right. Okay. All right, done. All right. So we start our tuition today. We're going to start our tuition today. All right. Okay. So, Newton gravitational law. Okay, now we are going to start from here. So now, what is Newton gravitational law? Newton universal law of gravitation state that. So you have to memorize the formula. So if you memorize the formula, then you can write this one on your own. What is this? This is, and this formula, it is given in SPM. F is equal to GMM over R squared. So this one is constant. So we said that F is directly proportional to M times M. So now the force between the two body is directly proportional to the product of the mass of the two objects, right? And inversely proportional to the square. Inversely proportional square between the distance of from the center of the two objects. Okay, so this is what you need to write. Okay, now whereas G is universal, G is gravitational constant. All right, whereas you can press from the calculator constant 39. All right, constant 39, you get that number 6.673. But in SPM, we normally use 6.67 times 10 to the negative 11. Right? So you use this value, and the unit is Newton meter square kg minus 2. And you need to memorize the unit. No need. Why? Why no need? You can make your own. If you don't know this, then you can derive the unit on your own. How? All right. So this one is Newton. All right. So I use other color. Right. Let's say this is Newton. Now this one I don't know. Right. This one is kg. This one also kg. So kg square. Now this is R. R is radius. Radius is meter. Meter square. So I time the meter up. Newton meter square. And then kg I divide down. Kg negative 2 is my unit. So this is Newton meter square kg minus 2, and you no need to memorize it. As I told you, you don't waste your time to memorize it. Okay. Now let's say we take one example. So this one is already got answer because earlier here we have done it already. So now we got one apple on this at the surface of the Earth. So Earth radius is 6.37 times 10 to 6. So find the gravitational force between the apple and the Earth. All right. So how do we do it? So F is equal to, I just take little example only. F is equal to GMM over R square. So F, you don't know, you want to find. Right? You want to find what is the force. Right? So G, we got it here. Right? You put it in. M, the mass, normally I will use the big M as the mass of the bigger object. Right? Small m is mass of the smaller object. Remember, it must be in kg, cannot in gram. So you change it to 0.2 over the R square. Over the R square. So how much we get it? So now 6.67 exponent negative 11 times 5.97 exponent 24 times 0.2 divided by R square, right? 6.37 exponent 6, and then I need to square it, right? So answer equivalent, yeah. Okay, 6.67, wait, exponent negative 11, you need to press it properly, time 5.97 exponent 24 time 0.2 divided by 6.67 exponent 6, divide by 6.37 exponent 6, and then square. All right, so what I have is 1.963. 1.963, we round off, we get this answer. All right. This is what we have. All right, so it should be easy for you. All right, now I am not going to do many example. All right, now here we simply, because of this is revision, so I try to cover it as much as we can by today, right? So we try to have a look on this example. Kedah, all right, Kedah 2021. Which of the following statement is correct about the gravitational force acting on the earth and moon? Okay, because of the earth sorry earth size is bigger, moon size is smaller. So now F, we know that F is equal to G M over R squared. It is directly proportional to, let's say, this is moon. Okay, we talk about, no, let's say this is rocket. Let's say rocket. Whatever, rocket, satellite. Okay, satellite. So now gravitational force of the satellite acting by the Earth is big G times big M over small m. Small m is mass of the satellite, right? So now this one is big. And the moon it is small. Moon it is smaller, and then this is a satellite, right? So F is a G M over R squared. The big M is mass of the moon, where mass of the moon it is smaller, right? So we can say mass of the Earth, mass of the what are they asking? Which of the following statement is correct of the force acting on the Earth and the moon? Okay, now this is gravitational force of the Earth against the moon, right? Oh, okay. Now it is not two objects. I'm sorry. Here it should be Earth and moon. Okay, so your force, you got one force acting to the Earth, and then you got one force acting to the moon. So this force is equilibrium. Mean this object pulled by the Earth and pulled by the moon will be the same, right? Because of F is equal to G M over R squared. Okay, F is G M over R squared. So if you are at here, so you are further. So this one is pulled by a force of the Earth, and then it also pulled by the force of the moon. So the force of the Earth, the gravitational force of the Earth against the moon, it is same as the gravitational moon force of the moon against the Earth. They are the same. Okay, same, man. All right. Because these two objects, it is fixed distance, so it will be the same. So we take some more example. Take some more question from here. Which of the planet produce the greatest weight of identical object? So weight, you need to know the weight is equals to mg. All right, weight is equals to mg. M is the mass. So we don't have the mass. We don't have the mass. So we take G. So the greater the G, the greater the weight. The greater the G, the greater the weight. So you will see this G, it is the biggest one. So biggest, so it will give you a biggest weight. Provided all of these one same mass. If the mass of the mercury is very, very big, so other story lah. Okay, so because of they don't give us the value of the M, so we just take the value of G. All right. All right, I hope you are okay. So we skip some. We try. We are not going to do all. I don't think we can finish it. So diagram 4 shows the object of the mass 3 kg is thrown at a 5 meter upward from the Earth's surface. You throw 5 meter upward. Now calculate the gravitational force act on the Earth by the object. Right, gravitational force F is equals to, right? So if you want, right, so you can use mg, right, very fast, right? You can use this one and very fast. Right, 3 kg, right, 3 g is 9.81, right? So you will get this value. 3 times 9.81 29.81. So you agak get 29.43. Agak. But because of this one is teacher, this one is 5 meter above. The further it is away from the earth, the smaller the gravitational force. So here, because of 5 meter, just very little compared to earth radius. So we don't calculate it. So we just take 9.81. But anyhow, you need to calculate this way, baru betul. This one is the correct way to calculate it. Okay, now how to calculate it? F is equal to GMM over R square. G M M G, big G, it is 6.67. Big mass, bigger mass of the object, it is Earth. Alright, Earth, it is 5.97 times 10 to the 24. Right, and then mass of the object, it is 3 kg. Here, 3 kg over R square. R square is Earth radius. Because of you are above 5 meter, right? 5 meter above, so you plus 5, and then square. So now if you don't plus 5, what happened? We are going to see it. What happened? Okay, now 6.67 exponent negative 11 times 5.97 exponent 24 times 3. Okay, and then divided by bracket 6.37 exponent 6 plus 5 cross bracket, and then you need to square it. Right, so what do we have? 29.44. So answer is A. Now just now I said, what if I don't plus 5? The answer will be the same, because 5 meter is very near to the earth. Alright, 5 meter only. Okay, so how? We press it again. 6.67 exponent negative 11 times negative 11 times 5.97 exponent 24 times 3. Alright, divided by, I said I don't want plus 5. 6.37 exponent 6, and then square. Okay. Yeah, teacher, why no change? Because I said 5, it is too little. 5 meter is very little, so it will not take any effect. So unless you said this object is 240 km. Okay, now this one take effect. You will see the effect very significant. Okay, you okay here? Okay, right. All right, so we continue from here. I think it is enough lah. Okay, now this question is important, so I want to try to see this question. So this question is diagram 7 shows a satellite orbiting the Earth. All right. Now here, the satellite pulled by a force to the center of the Earth, right? So this is gravitational force. So there is a centripetal force coming into this way, right? Coming into this way. Now what happened is, now because of the gravitational force and centripetal force will be the same, so it will keep on orbiting into the one orbit, same orbit, right? But if it is not, right? So once it is not, then what happened? So which of the trajectories A, B, C, D will the satellite follow? The linear speed of the satellite is less than the linear speed. So less than linear speed, it will be right. It will be this way lah. Right, the satellite will go lower orbit, and finally fall to the Earth. Right, it will not fall directly like that. Okay, it will not fall directly like that. So if it is faster than the linear speed, it will go to the higher orbit. It will go to the higher orbit lah. All right. Okay. Right? Any question you can ask. If you got any question, you can ask me. I will try to answer you. So I'm not going to do all the question here, all the example here. So we try to look at some structural question, how the question look like. Now diagram 2 shows the gravitational force acting on a boy and a girl, mass 70 and 53. So they are separated by 1 meter, right? 1 meter. Now, what is mean by gravitational force? Gravitational force is directly proportional to the product. Okay, you know how to answer this, right? Okay. Now, the second one is name the unit of F. F is K. F is equal to, now F is equal to MA. MA. M is kg. A is ms negative 2. Right? So this is the unit. Alright, the next one. Now calculate the F. F is equal to GMM over R squared. G, we got it. M is this boy, 70 kg. 53 is the girl. Right? Over their distance. So you find that the force between them is very, very, very small. Right? You cannot even feel it. Right? You cannot feel it. Okay. So next one. The boy and the girl did not experience excuse me. Did not experience the effect of the gravitational force toward each other. Why? Because their mass is very, very small relatively to the Earth. Compared to the Earth, their mass is super, super small. Right? Don't feel anything. Right? So now I skip some. I skip some. Feel like this question is interesting, so I do number 2. Alright, this is last year one, Melaka 2022. Right, this year I'm going to update more 2023 into the new new notes. Alright, so my notes update every year one. Okay, but haven't lah. I just get the trial paper. Right, so I need time. Right, so probably this this coming December I will start. Now I should do it now. All right, but I'm still having tuition. After I finish all the tuition, then I will do it. Diagram 2 shows the object S and of the mass M. You got the object S of the mass M. The mass is M. This is the object. So situated at the point which is at the distant r. R is here, and then small r is from the moon. So the mass of the Earth and the moon are m Earth and m moon, right, respectively. The gravitational constant is g. Right, using the symbol given, write down the expression for the gravitational force between the S to the Earth. Right. So F is a GMM over R squared. M, Earth. So you have to label M of the Earth. Small m is small m. Okay. Over R squared. Yeah, that's all. Right. So second one is the gravitational force between the S to the moon. Right. This distance is R, right? Okay. GMM, big M is mass of the moon. Mass of the moon times mass of the object, satellite, and then over R squared. R squared here. Yeah, same. So, and they said that if the resultant gravitational force exerted upon the object S at this point, it is 0. What does it mean by 0? Meaning that this point, it is in equilibrium. This point is equilibrium. What does it mean by equilibrium? Equilibrium means the force pulling here and pulling here will be the same. Right? Mean if I stay at this point, right, this force pulling to here and pulling to here will make my object cannot move. Right? But if I satellite, I put it to here, so this force it is stronger. So this satellite will pull toward the Earth. Right? This force it is weaker. Whereas if I put this satellite at this point, so this one it is further, so the force will be smaller, and the force toward the moon will be stronger. so it will be pulled toward the moon. Okay, I hope you understand. All right, next one. Next one then. Now next one. They ask you calculate the distance of the arrow of the object S from the center of the moon. So you know that this one and this one, the both forces are the same. So this force and this force, Earth to the moon, Earth to the object S and moon to the object X, it is the same. So I am going to cancel the same thing. G I cancel. Mass of the satellite are the same. So I got this one. So I got this one already. Alright. So they want calculate. What do they want? Calculate the distance of arrow. So you want arrow alone, right? So now what is the ME? ME it is given here. ME is 81 mm. So I'm going to substitute this one 81 mm. Right? 81 mm. So 81 mm, and mm I still can cancel. Alright. So I time it up. So 81 r squared is equal to 3.5 times 10 to 8 and then square. So this is what we have. Right. 81 r squared is this one. So you want to find r, you need to press 3.5 exponent at square, right, divided by 81, right? That is r square. So I want to find r, so I need to square root my answer. Square root my answer, I got this, right? I press here. So 3.89 to the power 7. 3.89 to the power 7. Right, this is what we have. Yeah, okay. I hope you're okay. All right, so we continue from here. Okay, now the next thing is the thing that we are going to see here is the relationship between G and gravity, not gravitation, the first one, gravity, and the distance between the object to the center of the earth, right? So we know that F is equal to mg, and then we know that F is equal to gmm over r squared. So we got these two, so we combine together. Mg is equal to gmm over r squared. I cancel the m, so g is equal to gm over r squared. Whereas, you see, G gravity is equal to gm over r squared. Alright, so whereas when it is outer, right, this is earth, so it is above the earth surface, the gravity will be decreased because of the distance decrease. So I time this r up, g r squared is equal to gm, right? When this one r increase, right, g decrease, so it is inversely proportional. You can see it is inversely proportional. But when it is inside the gravity here, not inside the gravity, what am I saying? Inside the radius of the earth, here to here, inside, so it is directly proportional. Meaning that the strongest gravity, it is at the earth's surface. Here, at this point, it is 9.81. But of course, at different places, they are slightly different, right? Maybe 9.82, maybe 9.05, like that. But commonly we take it 9.81. So when it is further from the earth's surface, let's say here it is at 0.2. This one is 6.3. So it is when it is further from the earth's surface, it is getting lower. But anyhow, here don't have gravity. Why? If the object is, we cannot go into here lah. But anyhow, if we can go into here, this one, why no gravity? Because it is centered already. Everything just want to pull to the center of the earth, right? Because of cannot pull in, so don't have gravity here. So when here, getting here, so it is bigger, right? Bigger, right? But it is directly proportional, right? Okay, if you got any question, please ask. Here it is a knot, right? I don't think I need to read it. This one is explanation for this one. Okay, I give you the notes already. Now, here, find the gravitational acceleration of object at the surface of the Earth, right? So, mg is it gmm or r? You cancel the m, right? G, you just substitute everything in, then you get the answer. All right. And now we see if the object it is far from the Earth's surface. All right. How? All right. Now a satellite is 480 km away from the Earth's surface. Right. Find the gravitational acceleration of the satellite. So how to do it? So now at the Earth's surface it is 9.81, right? So at further, so it will getting smaller. Right. How to calculate it? Now, so we are going to find F is equal to AMG, whereas G is equal to GMM over R square. So I cancel the M. So I want to find G, right? G, I don't know. G, I don't know. All right. So G, big G is 6.67. Right. I substitute in. And then M, big M, the mass of the Earth. Right. Bigger mass. Mass of the Earth here. 5.97. And then over R square. R square is here. This R is R plus H. R is radius of the Earth, and then H is how high it is. Remember, this one is in km. You need to be very, very careful, right? So what happened is, this one is in unit of meter, okay? 6.37 times 10 to 6 in meter. So this one I have changed to meter. So 480 km is times 10 to 3. Kilo is times 10 to 3. So, and then square it, I'll get the answer of this. If you press the calculator, you should be able to get it. Is that okay for you? Is that okay for you? It should be okay, right? No, not very hard, huh? Okay. We are going to try to have a look on this diagram. 3 shows the 3 identical satellite P and Q and R, which is located at a different height of the Earth's surface, right? So one is 150, 350, and 600. Okay, which one shows the correct comparison? So the nearer it is, the stronger it is, right? So now the gravitational force of Q is the biggest one. Q, it is the biggest one. Q more than P, yeah? Q is more than P. Q is more than P. Q is less than P. Salah. This one already out. A out. B and C correct. D, Q is less than P. Q is less than P. The further it is, the weaker it is. So this one out. So now we are going to see this one. Acceleration. So Q it is nearer, so it is bigger. So Q is more than P. Q is more than P. Yeah, this one is correct. Q is less than P. Salah. So answer is B. Answer is B. Okay. Right. We skip some. Alright, we skip some. We try to have a look into this one. Now, which of the graph shows the change in the acceleration of Earth? G with the distance from the Earth center, where G is the gravitational acceleration at the Earth's surface. So now it is the diagram look like this, if you remember. Alright, it is something like this. Remember, this one is G, yeah? This one is G, yeah? This one is R. Okay? Enough. We try to do structural equation. Some of the structural equation. Now, 4.1 shows the two bodies, which is P and Q, at the different mass at the distant r from each other. So the gravitational force F can be explained by the Newton universal of gravitation. Right? So this one I don't want to do it already. We do it so many times. Right? Now calculate the weight of P and Q. P is mg. Right? Mg. So mg is 9.81. So you just time it. Right? And then this m times g. Right? They are both, it is the same, 9.81. So we are going to take g is 9.1 given here. Okay, if we calculate the force between the P and Q, so we have to use G M over R squared. G M smaller mass 8 kg, bigger mass 20 kg over R squared. R is 175 cm. No, we cannot use cm. We change it to meter. Move 2 decimal. So it is 1.75 square. So you get it very, very small. Right? So they are going to attracted together? No way. Why? Because the gravitational force is too small, right? So it is not going to be attracted. Okay, so I guess this one will be good enough already. We try to have a look on centripetal force. So what is a centripetal force? Centripetal force is a force acting to the body in a direction toward the center of the circle, right? Meaning that here it is a centripetal force, right? If the objects turn to here, so this is a centripetal force, center punya force, centripetal force, center punya force. Sorry, right? Centripetal force, right? So now the formula is given is mv squared over r. Okay, mv squared over r. Okay, why it is like that? You will, if you go to form 6, you will learn it. I learned it in form 6, but I forgot how to explain already. I can slightly explain, right? Because of the v of the object here. Okay, I slightly explain and see whether you can understand or not. So now the object turn from here. The speed here and the speed here will be the same. The object turn to here, the speed same, but the direction it is different. So they are going to take this way to calculate it, right? This way is v squared over r is the acceleration, right? So I forgot what is that term already, right? You will learn it from 6. I learned it 20 years ago, right? So meaning that when the object change direction, even the speed it is the same, right? When they change direction, there is an acceleration. So they produce one acceleration this way. So actually they do it by using dy dx calculate. I don't know whether you learn dy dx or not. You have learned this one, differentiation, in form 4. Do you learn it? Do you learn dy dx? In maths, do you learn this one? No. Yes. No. No. Yes. Huh? Answer me. Do you learn this one? dx. They use dy dx to derive the formula. Okay, they use dy dx to derive the formula. No. No. Oh, you are going to learn it in form 5. Maybe. If not mistaken, MS. Got there. dy dx. Like y is equal to x squared plus 2x plus 3. Dy dx is 2x plus 3. Do you learn this one? No. Okay. No, then I explain to you also useless. Okay, leave it. So you just need to know the formula is mv squared over r. Okay, mv squared over r. centripetal force, right? So what is centripetal force? You just substitute in, right, mv squared over r. So m, mass of the pail, right? Mass of the pail, 4 kg. V is the speed at 18 over the r is 1.5. All right. So if you make it further, right, you turn the pail further, so the force will be stronger. Right. If it is nearer, then it will be weaker. Right. What is the I didn't answer this one. What is the observation if the pail is rotated with very slow speed? I didn't answer this one. Yeah. I do the calculation only. What happened if you turn, and then suddenly you make it slow? So the water will fall out, right? The water will fall out, and the pail will turn rotated with lower height, lower altitude, lower height. It will turn at the lower height, right? It will not turn that high, it will turn this way, right? And the water will go out, right? Is that okay? Okay. Now we take one more. We see this one. Now, what is the acceleration of the satellite if the linear speed of the satellite is 7620? If the radius of the Earth is given as 6370 km, right? So F is equal to mv squared over r. M I cancel, so I left A. So I want to calculate the acceleration, right? So I calculate A. So v square, yeah, v square. Make sure it is ms minus 1. Make sure ms minus 1. Right? And then this one is Earth radius. Earth radius is given as 6370 kilo times 10 to the 3. And then 500. So you need to plus 500. It is the distance from the center to the object. Center to the object. So you put it in, you should able to get this. Because it is quite far away, so it is not 9.81. It is less than 9.81. Right? It is less than 9.81. Right? I hope you are okay. Now, this is the experiment about the centripetal force, right? So you have done it in school. Of course, you have done it in school already. Okay. Now we continue from here. I don't want to calculate already. I calculate few enough already. Okay, so we try to have a look into this question. Diagram 3 shows the orbit of the rocket along the curve r, whereas it is moving with the linear speed v, right? If the speed suddenly decrease until half of it, right? Which one PQRST will become the new orbit? So it will be slower, so it will be go to Q. It will go to Q. It will forward to the lower orbit, or it will be this way. The more correct way it is something like that. Like that. Maybe. Right. More correct part. But anyhow, Q is the best answer. Okay. Okay, we try to have a look into this question. Now, the radii of the circular orbit of the two satellites A and B, we got A, we got B, A and B, right? So, which is 4r and 4r, respectively. If the speed of the A, it is 3v. So, this A, it is moving at 3v. What happened to speed of the satellite B? How to do it? We got F is mv squared over r. mv squared over r. So this and this, right? So I'm going to substitute this one and this one. MA, M mass and mass B, it is the same or not? I want to know. Mass A and mass B, they are not given. Right? Not given should be the same. If not the same, then you will tell me, right? So it should be the same, so I cancel. Right? VA and VB, split A and split B, of course, it will be the different. Why I know it is different? If the same, you won't ask me what is the velocity, right? Common sense. So RA, it is 4R, right? 4R. 4R. Right? RB, it is R. So I cancel the R. I cancel the R. And VA it is 3V. They said one, not I say one, right? 3V. I'm going to substitute in. So now 3 square I got 9. V square I got V. 4 still left here. R cancel already normal. So VV it is 9 over 4 V square. So because I want to find VV square, this is VV square. I want to find VV. Square root of the answer. Square root of the answer. 9 square. Square root of 9 it is 3. Square root of 4 it is 2. Square root of V square it is V. You got plus minus or not? Yes, but we don't take plus minus. Physics don't. Right? No need to take plus minus. Just leave it as positive will be okay. 3 over 2. Answer is 3 over 2. Okay? Are you okay with here? Alright. Okay with here, right? Now, alright. Let me see this one. I am not going to do all. I said I'll do some only. Oh, so many. I feel like I want to skip some. Cannot do all. Do all we cannot finish. Okay. We see number 3 lah. See number 3. Diagram 3 shows the weather forecasting satellite orbiting the Earth with a certain height with a radius of r and the linear speed of v. Hi sir, can I get the PDF out? No. This one is only for my student only. This one for my student. If you join my tuition, then you can get it lah. This one for my student only. Okay. Because my student, they are paying for the material fee, so they will get it. Every week I will send this one. So here okay, diagram 3 shows a weather forecasting satellite orbiting the Earth at a certain height of the radius orbit r and the linear speed v. All right, stack the factor affect the linear speed. Okay, so the formula is f is equal to ab squared over r. So now one of it is mass, one of it is v to affect this, right? So you just need to take one only. All right, distance between the center of the Earth to the satellite, here to here, mean r will affect the v. Okay, next one. A weather forecast satellite with a mass 419,725 kg orbiting the Earth at the height 600 km. So calculate a linear speed. Right? F is mv squared over r. F is gmm over r squared. You can try to build your own formula. The formula on your own, not your own formula. Build the formula on your own. Cancel the r. Cancel the r. Cancel the m. Cancel the m. So left gm. Gm. Alright. Gm. And then r still got 1 at here because I cancel 1 away already. Still got 1 r. So how much is r? You need to know. Radius of the Earth. 6.37 times 6. And then how far it is? It said that it is 600 km. 600 times 10 to the 3. Alright, put it in. So you substitute in, you're able to get this. Normally, the speed of the satellite, it is about 7,600 something. Below 8,000 lah. Alright, normal speed lah. Hmm. 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 Okay. I want to ask you, I suddenly think of one very stupid question. Why the satellite cannot move very near? We don't put the satellite very near to the Earth's surface, like 3 km, 5 km like that. Why we don't put? I want to ask you. I suddenly think of this question, so I see whether you can understand or not. Why? Normally, the satellite, we have to put it at. We have to put the satellite at about 400 km. Here, 400 km from the Earth's surface. Why don't we put like 3 km, 5 km like that, right? Okay, 3 km you can see it very easily. Why we don't put it at here? Hmm? Gravitational acceleration become lower? No. At the Earth's surface, the gravitational force, isn't it bigger? Here, the gravitational force, isn't it bigger than here? Right. I mean, if you're further, the gravitational force, gravitational acceleration is lesser. Further, then it will be more. Right. Not enough centripetal force to rotate the Earth constant distance, cause it will get affected by the gravity and fell it to the Earth's surface. Quite true. Quite true. Yeah, I accept this answer. Right. To be honest, same as the question, why the aeroplane cannot fly? Not cannot fly. They won't fly like very low altitude, like 3 km, 2 km above the surface of the Earth. Right? They must fly at a very high, because of here when they turn it here the density of the air so high, density of the air very high. So density of the air at the higher altitude very low. So here don't have friction. Not don't have friction. The friction is this lesser. So easier for it to move. Right. So if this one want to move, got friction. So hard to move. Aeroplane cannot move here. If move here, the frictional force will cause your engine to be, you need more engine force. You need more thrust to move forward. So you will take a lot of petrol. 很吃油. Oh, okay. I use Mandarin. 很吃油. 不可能. So, and then very hard to move, right? Because of friction, right? Okay. Friction, and so when the friction here, you got a lot of friction, mean your velocity, it is slow, right? So you want the centripetal force is F is equal to AV square over R. So now the energy that you need is you need to provide high velocity so that you got a high centripetal force, right? If the velocity is low, then you fall back to the Earth. So because of the density of the air is too high, the frictional force is too high, cause the velocity here very low, so the centripetal force is low. So it is not logic to put. And then second one, it is if you got mountain, it is high, so easily block. Kena boom. So the highest mountain it is Everest. Everest is about 8 km only. 8 km. You put 10 km also cannot. Right? Also cannot. Too long. Cannot. Normally it's 200 something km to 400 km. Okay. All right, so the next one is centripetal force. Centripetal force is ma. Ma is mv squared over r. Mv squared over r. Whereas a is v squared over r. You cancel the m. So v squared over r. V is here, and then r is here. Right? So you get the answer. So which is, you must know it is less than 9.81. It is slightly less than 9.81. You okay with here? This is the one. I see want to do or not. This one, geosatellite, geostationary satellite. We haven't later we baru go lah. Right. So okay, never mind. We do this one. Alright. We are doing revision now. Alright. Diagram 4 shows a few man-made satellites from various countries. Alright, what is meant by geostationary satellite? Geo mean always same geographical location, right? Whereas the orbital period, it is 24 hours and must be same direction, right? Must be same direction of the Earth, right? So give two characteristic. Orbital period is 24 hours and then same direction, right? Cannot opposite direction, All right. Now a geosatellite of the mass 1,200 kg is placed as 4.23 times 10⁷ at the center of the Earth, right? Now F is equal to mv squared over r, right? So now m I cancel, right? Left gm over r. R1 I also cancel one away. Left, this one is v square, left v square, left v square. This r cancel already. This one left one r here. This one left gm because the small m already cancel. So you substitute in, you get the answer, right? You get the answer, right? Answer here is 6,000 something, right? The velocity, right? This one, who is expert, right? Expert, Elon Musk, the richest man in the world, right? The one that built make the electrical vehicle one, right? Electrical vehicle. The Tesla, you know the Tesla? Tesla. Okay, Tesla. I got that one. I want to see. Wait, give me one minute. No. Okay, leave it. So now the Earth gravitational pull, F is a gmm over r square, whereas g, m, big M, small m is the mass of the satellite. Alright, then over r square. Right, r square is here. Just put it in. Right, make sure you know how to press the calculator. Make sure. Right, so now I don't press for you already. Right, you press so many times, you should be okay already. Now what happened to the satellite is the speed, it is lower than the orbital speed, right? So if lower, it will fall back to the lower orbit, and finally it will fall back to the Earth's surface, right? Because of the friction, and it will produce heat and burn. This is one of the question come out when in SPM already, if not mistaken, is last year came out. Okay, now any question here? Centripetal force, I don't want to do already. We do so many times already, right? I think it is enough already. All right. I think it's enough already. Centripetal force, right? Yeah, I got this kind of question. I feel like want to do. We do fast. I do fast. It was so long. Never mind. Do it. This is SBP 2021. Diagram 7 shows the athlete spinning the hammer, and then throw. Okay. You know, like my daughter, her school got one throwing this hammer, right, and then kena his friend and then go to hospital. Oh, so dangerous this one. The small kid cannot play this I don't know why their teacher asked them to play this. Forget about this. The centripetal force acting on the hammer when it is rotated at the tension string. So centripetal force, what is centripetal force? This one is the force acting onto the body into the direction of the circle of the circle. Mark the direction, so mark it toward the center. Right? So now formula F mv squared over this calculation I don't want to do already. I'll do so many times already. So I'm interested at this one. Right? Diagram table 7 shows the characteristic of FGH hammer throws to involve into the hammer throw sport event. You got this. Based on the specification in table 7, state the suitable characteristic of the hammer throw that has a higher rod tension when it is rotated. Now, give the reason, right, suitability of each characteristic. So, the string of the steel string must be short. Yeah. F is equal to AB squared over R. Length of the string. Okay, this one I go up. I want the length of the string. So now I time the R. The string it is here to the center, right? You throw this one. Now R. R is equal to MV. So I thought about this one is a constant. So if this one is big, then this one is small. Right? If the R is small, then F is big. If you want more force, more centripetal force, so the steel string had to be shorter steel string. Longer, then it will reduce the force by using this formula. Okay, by using this formula. Okay, next one, the linear speed of the hammer when it is rotated. All right, linear speed. So now if linear speed, we still use the same formula. F is equal to mv squared over r. Right, r I go up. R is equal to mv. Right, if you want bigger speed, so the force will be bigger. So r I can take it as the same. So I want shorter, I want bigger speed. Right, shorter and bigger speed. Shorter, so this one h. Bigger speed, this one. So answer is h. Yeah. All right. We continue from here. All right. So this one is SPM paper. Yeah. This one. That's why I remember. Right. 2021. It's 2 years ago. Come out. Come out. It is the same, so I don't want to do it already. Right. So we move very, very quickly to Kepler law. So I try to cover everything today. Right. Kepler first law. First law said that, you know who is Kepler? Kepler, his teacher, you know who is his teacher? Kepler's teacher. If not mistaken, it is Galileo Galilei. You know who is Galileo Galilei? Galileo Galilei. When he was very, very young, alright, this Kepler, he already followed Galileo Galilei. Galileo Galilei is the one that invented the astronomical telescope. And then because of this, so he keep on following, and then this Kepler got very, very good habit. He like to mark down everything that he observed. That's why he got his Kepler law. From, he observed the sun and the moon and the star every day and mark down the location. Baru got the data. Right? End up Because of Newton, he proposed a law, Newton gravitational law, ba, right? And then after that, he used Kepler's statistic. Kepler got a lot of statistics and then combined together and calculate, yeah, June, Newton law is correct. Baru got Newton law is proposed. No Kepler also no Newton law. So Kepler very, very smart also, right? But he is not the one that thinking of how it is calculated. He is observing where it is, how it is, and he used his proof to show this one. All right. So first law, it is called law of orbit. Right? All planets move in elliptical, he said. All right. But there is two focus, right? Earth, it orbit this way at the focus here with the sun at the focus one, and one more focus at here. So it is called law of orbit. Ellipse at sun at the focus, right? Second law, a line that connects the planet to the sun sweep out equal area in equal time. It is called law of area. This one always come out on Kepler second law. Most of the time it come out in the adjective, so you need to know. So this area, if I calculate the area here, and then it's same as this area, provided this one is 30 days, this one also 30 days. If I take another one, let's say here 15 days, right? So I calculate here 15 day punya jalan 15 day. So this area I calculate, it is the same as this area. So that's why it's called law of area. Okay, and the further it is from the focus, further it is, the slower it is. The nearer it is, the faster it is. So when the earth they rotate to near to the sun, so the point nearer to the sun will be faster, right? So now here you see here 30 day, wow, travel so far. Here 30 day travel so little only, right? But the area it is the same, right? Right? A line that connect the planet to the sun, right? Planet to the sun, sweep up equal area, equal time. Okay, equal area, equal time. And then Kepler third law. T square is directly proportional to the R cube. It is called law of period. Okay, so most of the calculation is here. This question they can ask you to prove it, prove this one out. Okay, so how to prove it? It is shown here. So mv square centripetal force over r is equal to gmm over r square. This one is force, this one is force. So I want to find mv. So this m I cancel, this m I cancel, right? Then r I cancel one, left v square. V square is gm over r. Okay, so whereas we know that v is velocity of the earth rotating the sun by one turn. So it is elliptical, right? But we have to take it as circle. If not, we cannot calculate, right? So we take it as circle. Circle is the distance traveled is 2 pi r, right? Velocity is equal to distance over time, right? Distance is, it go one round, elliptical. I know it is elliptical, but we take it as 2 pi r, right? Because of elliptical got formula or not, got too hard for you to calculate. We take it as circle, then it's easier for you to calculate over the period. This is velocity. So we got this formula. So we know that v square is here. I substitute in 2 pi r over t, and then I got t squared over 4 pi squared over gm. Okay, and this one come out, when they come out, they calculate exactly same as the Newton proposal. That's why I said Newton have to thank Kepler, right? If that time no Kepler, then Newton's this gravitational still cannot be proved, right? Not proved, like no people can tell it is true or not. So this one is a constant, but we use this constant. No, we don't use this constant. What is constant mean the number always fixed. If you divide by t squared over r cubed, the distance, remote cable, they always will get this number. It will always get this number. Okay. So because of it is constant, so we use this formula. T1 over T2 is R1 cube over R2 cube. T1 square over T2 square is R1 cube over R2 cube. Or I like to use T, can be this way, yeah? T1 square over R1 cube is T2 square over R2 cube. Alright, meaning that up to you lah. You bring this one down, this one up, also cannot. Right? No worry. Okay. Now how to do it? How to do it? Okay, like okay, we take one example. The radius of the orbit of the planet of Mars can be determined by comparing the mass with the orbit of the Earth. What information need to determine needed to determine the radius of the orbiter of the mass? It is the orbital period of the Earth and Mars, right? So you have to do the information that you need to calculate is, you need to know is the Earth and the Mars, the orbiter. Mean this one turn one round is how long time? Earth we know, turn one round, it is 1 year, right? Mars, then have to ask Kepler. Kepler got record. You record every day, right? So probably Kepler it is so free. I think Kepler at that time, if he got handphone, then he won't do it. You know why? Because he's too free, nothing to do, then he look at the sky and then record the time. Right? If he got handphone, he play PUBG already. He play games already. What for? You ask my son to look at the sky, you think he want or not? He won't. He don't want to. Okay. Okay. Now here, the radius of the orbit of the Earth, it is 1.5. Okay, we label here Earth, it is 1.5. 1.5 times 10 by 11. Okay, so Earth it is 1 year. Turn T it is 1 year. Alright, so Mars it is T, it is 1.88 years. Alright, this one unit year, this one must be unit year. Alright, don't use a different unit. Cannot. So I always put the unknown R2 here. R2 you cube. Alright, R must be cube, T must be square. Alright, so R2 cube, so I over 1.88 square. Alright, over this one square. Right, is equivalent to this one is R, so this one I'll put R. 1.5 times 10 to 11 cube divided by 1. Right, divided by 1 mean no need, 1 square mean no need, no need square. So how to press it? So I need to show you how to press it. So it is 1.5 exponent 11 to the power 3 cube, right? Cube times 1.88 and then square equal. So I've got this one, the radius, but this radius is cube, so I need to cube root equal. So I got 1.37. Salah. One more time. 1.5 exponent 11 cube, yeah, time 1.88 square equal, then cube root equal. Sorry, I pressed wrong. Okay, it is 2.28 times 10 to 11. 2.28 times 10 to the 11. I hope you're okay. I hope you're okay. Okay. I don't think we need so many examples. Right? One or two examples. Okay, now I ask one. Right? I ask one. You do on your own. I give you question. You try to do. Distance of the moon. Okay. So I got a nice search, right? So distance of the moon to the earth is 384,400. Right? Moon. Okay. Moon. My question is, okay. So this is sun, this is earth, this is moon. Okay. Moon to the sun should be moon to the sun. Moon to the sun. Wait. Moon to the sun. No, let me think. Moon to the sun. Cannot. I am asking. I think of what I want to ask first. Moon is rotating sun. Moon is rotating to the earth. Okay, now, never mind. I change. This is earth. Okay, I set a question. This is moon. Now, this moon, they go, one round, to the earth, it is 27 days. The T period, is 27 days. Okay, they go one round. Okay, how far it is from here to here? How far? It is 384,400. So R is 384,400 km. Okay, now there is something here. There is a satellite that I don't know how far. I know how far. I know how far. It is distant here to the center of to the surface of the earth. It is H. I call it H. H is 500 km. And radius of the earth is 6.37 times 10 to the power of 6 meter. Meter. Okay, so find the speed, not speed. Find the orbital period of the satellite. Okay, help me do this question. This is a satellite. This is my question. Any other thing that I miss out? No. Try to do this question and then give me the answer. I set the question on the spot. Okay, do it. I'll be right back. I go to the toilet for a while. Yeah, back. Already? I'm waiting for your answer. Eh, none of you answering? I'm doing revision with you. You don't answer. You want to wait for answer only. Oh. I give you 2 more minutes before I do. In days, how many days? Are you doing it? Hello? Okay, I'm going to do it. All right, time's up. All right, if you do it, you still can comment. All right, so now t square, all right, this t I don't know, over r square. R is 6.37 times 10 power 6 plus 500 times 10 power 3. All right, and then this one have to be cubed. So this one I done already. So this one t is 27 square over r cube. R is 384,400 times 10 power 3. And then cube. So press calculator. So I guess the answer is about 1 because the height when it is 480 to 500 km, it is geostationary satellite. So geostationary satellite mean it is the orbital period is 24 hours, mean it is 1 day, about 1 or 1 point something lah. Right? See whether you are correct or not. 27 square divided by open bracket 3 at 3 at double 4 double 0 to the power 3 and then cube. Okay, time this one, time open bracket 6.37 exponent 6 plus 500 exponent 3 and then cube. Okay, then this one is equal to t square, equal to t square. Then t is square root. Do I press anything wrong? 0.064. 0.064. One more time. 27 square divided by 3 8 double 4 double 0 to the power 3, then cross bracket cube time this one time 6.37 time 6.37 exponent 6 plus 500 exponent 3. Okay, and then this one have to cube, equal. Yeah, correct. Square root, my t is 0.064. Do you get this number? Not 1, no? Probably the one that I give is not so correct. But anyhow, t is equal to 0.0645 days. Right? Meaning that it is very, very fast. Time, 24 hours. So it is 1.5 hours. It turns very fast. 1.5 hours, it will turn 1 round. Okay? 1 round. 1.5 hours. Like 1.5 hours. So this one is not geostationary. Right? This is 1.5 hours. It will rotate the earth for one orbit. Okay? Question? Okay, so we come back to here. Right. Now, question then I don't want to do already. Left a half hour, so we try to do the last part. Right, revision, last part. Kepler law 1, Kepler law 2, Kepler law 3 already. Okay, now this one actually it is the same thing, right? Man-made satellite here. Okay, man-made satellite. Whereas mv square is over r is equal to gmm over r square. So I cancel the m, cancel the m, cancel the r, cancel r. You got v square is gm over r. Whereas r is, because of satellite, is r is big r plus the height, like what I told you just now. So this one is not so special. So nothing special from what we have done, right? Man-made satellite. But this thing you have to know lah. We got two type of satellite. One is geostationary. Geostationary, the T is 24-hour, and then same direction. Now it has a special orbit named geostationary Earth orbit, right? So always above the same geographical location, right? Example, Mesa. Non-geo, normally in lower orbit or higher orbit, right? Normally it's lower orbit, right? Can be same direction, can be opposite direction, right? Same direction, but your period cannot 24-hour. Opposite direction can 24-hour, can 20 opposite direction can 24-hour, right? So above the different geographical location at the different time. GPS, weather forecasting, all this is using non-geo, right? Non-geo. Geo is communication, right? Remember, this one you have to remember. Okay, and next one is the thing that we are going to learn fast here. We go through faster go through. Escape velocity. Escape velocity. Now, first thing that you need to know is escape velocity. Memorize it. Minimum velocity that you need for the object to overcome the gravitational force of the Earth and escape to the outer space. This is called escape velocity. So this is the formula for potential energy, negative gm over r, right? Gmm over r, and then kinetic is half mv squared plus kinetic. Potential plus kinetic is all the energy is equal to 0. So you can bring this one to here, become positive, right? Become positive, right? So you got v squared is 2gm over r. This is the escape velocity formula, right? So v is 2gm over r, escape velocity. Okay, mean our Earth, if you want to escape from the Earth, you need to have 11 kilometer per hour, right? 11 kilometer per hour for Earth, right? How to know it? Okay, now here, Earth, the escape velocity is 11 kilometer per hour, not per hour, sorry, 11 kilometer per second. You baru can jump out from the Earth, right? So we need how to calculate, right? V is equal to 2gm over r square root. Okay, is 2. G is 6.67 times 10 to the negative 11. Mass of the Earth is 5.97 times 10 to the 24. R, radius of the Earth is 6.37 times 10 plus 6. So we try to calculate it. 2 times 6.67 exponent negative 11 times 5.97 exponent 24 divided by 6.37 exponent 6 equal to 2 times 6.67 exponent negative 11 times 5.97 exponent 24 divided by 6.37 exponent 6 equal. Then square root equal. So you get 11,000 meter per second. Right? That's how we calculate it. Okay. So because of the because of the V is equals to 2gm over R. So now the escape formula depends on two things, right? This G is a constant, so it depends on the size of the mass. The bigger the mass, the bigger the escape velocity. Means harder for you to move from the Earth's surface. And then V, I get rid of this square root. V is equal to 2gm over R. Just compare only this R, I time it to here. So R radius is bigger, means the size of the planet is bigger. So the escape velocity, the R is bigger, mean the V will be smaller. Wait. R is bigger, V will be smaller. Can I answer it this way? Wait. R, we compare these two. All right. Let's say Earth and Moon. All right. Earth is bigger, so escape velocity is bigger. Right. So the orbital radius it is smaller, so this one is smaller. So we cannot use this way. Right. Because of you got square root, we cannot take this one out. Right. So we can take the m. The bigger the mass, you see, the bigger the mass, 24, this one 24 to the power of 24, then to the power of 22, right? So the bigger the mass, the bigger the escape velocity. The smaller the mass, the smaller the escape velocity. All right, this is what we have. It depends on the mass and radius. Okay, so let's say we take one easy example. Just take one, okay? Our time is not enough. 9:30. Our tuition finished 9:30. Find the velocity needed for the rocket to move from outer space. So this one I show you already. Right? 2gm over r. Okay. If you want to find the escape velocity, so you need to have the value. You just substitute in, then you get it already. Meaning that, what does that mean? What does that mean? This is Earth. This is Earth. There is a rocket. There is a rocket. There is a rocket. Elon Musk punya rocket. Okay. So this rocket want to escape to the outer space. Right? Outer space is here. So this is outer space. This is outer space. Yeah. Now I want to go out to the outer space. So I need to have 11,000. Right? So my rocket, Elon Musk make the rocket, this rocket only can reach 5,000 meter per second. The maximum speed. Okay. Then what happened is the rocket cannot. Can fly or not? Can fly and then cannot go out. Can fly, then cannot go out. Cannot go out to the outer space. Right? This is called escape velocity. Now, yeah, okay. Now, teacher, I know liao. So I make the rocket, Elon Musk said I make the rocket, 12,000. Yeah, June, 12,000. 12,000, yeah, Earth punya 11,000, right? 12,000. But he forgot, you cannot visit a bigger planet than Earth. You visit, then you cannot come back. Because if you reach there, yeah, the bigger planet, your rocket here already, you reach the Earth atmosphere, and then you fall back, fall into the Earth, not fall into their planet. So this planet is bigger than Earth. Mean their escape velocity maybe is 15,000. So you got 12,000, you cannot go back already. You are going to forever stay there. Unless you can build another one, better one, can reach this speed. Then you can come back. You get what I mean? Okay. Okay. Now we are going to see what is the use, right? What is the benefit? Okay. Now, the benefit of implication of high escape velocity. With high escape velocity, Earth is protected with the atmosphere. If we don't have high atmospheric high escape velocity, we don't have it. So meaning that this is our Earth. Now we got atmosphere. If you want to, the A want to jump up. Wait, give me one. If the A want to escape, you need to have 11,000. Baru can jump out, right? So normally the A is moved with 500. So the A want to jump up, cannot jump up, cannot jump up, cannot. It will form atmosphere. So atmosphere, so that you can live inside the atmosphere. It will protect you from the UV of the sunlight. Okay, it will protect you. So the molecule of the atmosphere is moved with 500 so that it cannot escape. All right. So AJ, you drive Ferrari. You drive. If the escape velocity is 11,000, right? So you drive 250. Not jet only move to 250. You move with 100, so you will not escape from the Earth. You don't need to worry. You use jet. You use rock. Not jet aircraft. All cannot reach this speed to escape from Earth. All right. That's why it can protect us. So rocket need to be more than 11,000 kilometers per second so that it can go out. It can go out. Okay. Now next one. I jump a bit because I want to finish it. We do one. We do one question. Yeah, you got one question. Normally, when you ask in the class, I will not answer lah. But today is I give free class, free trial, so I'll answer your question lah. Here. Since you're asking, here, so I'm answering you. Because normally when I'm teaching, I'm not look at Telegram or WhatsApp unless I ask you to do homework. Right? The escape velocity of the Earth, it is at okay, never mind lah. They say at and at. Calculate the escape velocity of the mass 100 times that radius 4 times of the Earth. Okay. Now, escape velocity V is equals to square root of gm over r. Okay. Now, this one they said this V is at 1,000 meter per second. Right? At 1,000 is equals to square root of gm over r. So normally I don't like to square root, so I square both sides. So square both sides, I will get 8,000 square. Oh, I use km lah. I don't want to use this one. I use km. Use km. So 8 square. 8 square is 64. Right? I don't want to use this. 64 is equals to square root of no more square root, sorry. Gm over r. Okay, I got the first equation. Right. So now you are going to have one more. You are going to have escape velocity for other planet. You don't know. Alright, escape velocity V prime, I don't know. But this G, it is the same. Mass, it is 100 times. So times 100. Well, R is 4 times 4R. Okay. So this one, I want to know how much. So now 100 I take out, 4 I take out. So 100 I take out, 4 I take out. Gm over R, right? Gm over R how much? 64. 64, Gm over R. So it is V prime, it is 100 divided by 4 is 25. 25 times this one. This one is 64. 64. 25 times 64. 25 times 64. You got 25 times 64. 25 times 64. Right? It is 1600. Right? So now this is the v square. This one is v square. I squared it. This one is v square. This one is v square. Sorry. This one is v square. So I need to square root of that v square. So I get the v. Right? V is square root of this answer. Right? So I get 40. Answer is 40. 40. So this one is v square. Sorry, just now I squared it because I want to get rid of this one. If not, still got this one. Kacau kacau, so hard. Right? So this one is v square. V square. V, this one is v square. V square. This one is 64 square already. Get it? Get it? Alright. Okay, we come back to here. Come back to here, huh? We do one more question before we end the class. Right. So diagram 2 shows a spacecraft of launch in the space from the Earth's surface. From the Earth. So what is meant by escape velocity? Minimum velocity that needed for the object to overcome the gravitational force of the planet. Escape to the outer space. Right. Formula is V is 2gm over r. Right. So 2gm mass of the Earth. Mass of the Earth over r. Mass, you get 1.12 times 10 power 4. This is what we had learned before. For Earth 1.1 kilometer per second. Next one. Next one. If the velocity of spacecraft is 8,000, will it ever? No. No. Why? Because it is because of the velocity of the spacecraft is less than escape velocity of the Earth. You have to greater than baru can escape from the Earth. Less than, sorry, tidak boleh. Okay, now. So we take one more question. So much calculation. We take number 9. Do 1 or 2 calculation at least. Okay. Now the escape velocity of mass, it is 5. Right? Escape V is equal to square root of 2gm over r. Okay, so it is 5. This one is 5.02. 5.02. Assume that the mass of the mass it is r. Okay, so what is the escape velocity at the 0.3 r from the surface of the mass? Okay. This is mass. So now the escape velocity here is 5.02. Right? Escape velocity. So if you are going to have here somewhere higher here, which is 0.3 r. Right? 0.3 r, 0.3 r. 0.3 r. This is r. This is 0.3 r at the Earth's surface, from the Earth's surface. Meaning that what is the total r here? Total r is 1.3. There is this r. Here it is 0.3 r. So it is 1.3. Okay. So V prime it is gm over r. How much is r? Mass, they never said change, right? R is 1.3 r. Okay. So what do you have is, now 5.02 is equal to 2gm over r. You got the first equation. Then second one is 1.3 r, big r. Okay, so you take out the 1.3, take out the 1.3. 2gm over r still the same. So this one is how much? This one is 5.02. 5.02 times square root of 1 over 1.3. You get the answer. So 5.02 times square root of 1.3 inverse. You get 4.4. So you get the answer of 4.4. Okay? Should be okay, right? I'm going fast, I'm going fast. revision, no choice, have to go fast. If not, how to finish one chapter? If I use this speed to do in the class, GG. GG. You will GG. I will GG. Everybody will GG. Okay. We'll do one more question before I end the class. Alright. Okay. Now last one. What is the minimum velocity required for the object to launch out of the space? Right? V is equal to 2 gm over r. Just this formula. 2 gm over r 11.2 times 10^4. You do so many times. This one you can memorize the answer already. Earth punya, right? It is 11,000. Right. So in fact it is 11.211,200 kilometer. Not kilometer, meter per second. You baru can escape from Earth. Now, any question before I end the class? So I have finished this revision chapter 3 for you. If you got any question, you can PM me. You can PM in the Telegram group. You can PM me in the WhatsApp. Right? And I want to do a bit of promotion. Promotion for my tuition. Next year, as I told you, next year tuition will be very difficult for you. So you have to join earlier. My tuition, online tuition only next year. Next year, the fees will be RM65. RM65. If you got any friend want to join, it is not from PTSC, not existing for at PTSC. You join, right? You write the name of the people that invite you. And you invite people every month. You got 10 ringgit of rebate. Mean if you able to ask 6 person, 1 month you only pay 5 ringgit for the tuition fee. If you ask 10 person to join the tuition, right, you'll get 100 ringgit rebate. Mean your tuition fee only 65, you can get 35 ringgit every month. I pay you, not you pay me. Right? Not I pay you. Tuition center is going to pay you. Right? So you invite your friend to join. So invite the more your friend to join, you get free tuition. Right? You get earn money also. Right? Every month you earn free tuition and earn free money. Okay? The form here. Go fill in the form. Alright, go fill in the form. Alright. I'm going to stop here. Any other question before I end the class? Any other question before I end the class? If no, then I am going to stop here. Alright, I'll see you next week. Okay, bye-bye.
上了2个小时的课，大家都辛苦了，谢谢你们有专心上课，下个星期。